I will be carrying out the math test series of the 10th standard NCERT, and then we'll be doing with each and every chapter. I will be giving you the online solution of each and every question. So we'll start today with the first chapter, and along with the solution I will also give you the concepts related to them. I hope you find it useful and you will share it with your friends also, and they may also join. So let's start with the first chapter, that is the real numbers. So when we do with the real numbers, then for that we should understand what is the number system. So for that number system, we know about the natural numbers. Natural numbers are denoted by letter N. They start with 1, 2, 3, 4 and so on. Then we have whole numbers. Whole numbers is W, starts from 0, 1, 2, 3, 4 and so on. Then we have integers. Integer is denoted by letter Z. Integer includes all the negative numbers, 0 and positive numbers. So all the negative numbers will write down dotted. I am writing down few negative numbers, -3, -2, -1. It also includes 0. And then 1, 2, 3, all the positive numbers. Then we have rational numbers. Rational numbers are denoted by letter Q. Rational number you have studied in 9th standard, they are the fractions. And none of the fraction is defined with denominator 0. So here we have to write down that denominator is not equal to 0 because it is undefined. Then we have irrational numbers. Irrational number is denoted by letter I. So these are root 2, root 3. Root 4 can't call it as irrational because root 4 is value 2. So root 2, root 3, root 5, root 6 and so on. This is actually a lot in 9th standard, and this 9th standard concept, if you want, I can explain you in all detail, and for that I will make a 9th standard series, math series, and there I will explain it. But presently you understand irrational number is root 2, root 3, root 4 is included because the value is 2, and 2 we can write it as 2 upon 1. Then root 5, root 6, root 7, root 8, root 9 we cannot write because root 9 value is 3. 3 can be written as 3 upon 1, so we cannot include that as well. Then root 10, root 11 and so on. These all numbers are called as real numbers. These all numbers are called as real numbers R. And then we have imaginary numbers that you will study in 11th standard as complex number. So these real numbers are all these numbers, and those numbers which are not real are the complex numbers. So that we will consider it in 11th standard. So why do we study real numbers over here? So real numbers includes all these numbers, and in this chapter we are going to study about the HCF and LCF. So before we learn about HCF and LCF, which you have already known, which you already know how to find out the HCF and LCF, but we are going to just revise them again as with the simpler methods. So till now we have studied about prime factorization. For example, prime factorization of 12 is 2, 6, 2, 3, 3, 1. So 12 we can write it as 2 into 2 into 3. So why do we do that? Here comes the definition of numbers. So I will explain what is prime numbers. So prime numbers are those numbers which are divisible by 1 and itself. It does not have any other factor. If it is 2, so the factors of 2 will be only 2 and 1. If it is 3, factors of 3 will be only 3 and 1. If it is 5, factors of 5 will be 5 and 1. 7 has the factors 1 and 7. So therefore they are called as prime numbers. 11, factors of 11 are 11 and 1. So the prime numbers are those numbers which have 1 and itself as a factor. But when we consider 12, 12 has factors 2, 2, 3. So we don't say 2 times, we say it has factor 2 and 3. So therefore 12 cannot be considered as prime number. So if a number is not prime, then it is called as composite. So composite number have any other factor. So composite number. One is called as unique number. It is not included in prime as well as composite. So 1 is a unique number. So therefore composite numbers can be any other number apart from 1 and prime. So therefore we can call it as 4, 6, 8, 9, 10, 12 and so on. They are all composite numbers. So this is what we have learned prime factorization. Actually mathematically it is called fundamental theorem of arithmetic. Fundamental theorem of arithmetic means any composite number can be written as product of primes. Fundamental theorem of arithmetic means any composite number can be written as product of primes. So as we have done this example over here of 12. So 12 we have factorized it as 2, 6, 2, 3, 3, 1. So this prime factorization is nothing but fundamental theorem of arithmetic. So this is nothing but fundamental theorem of arithmetic. So on this fundamental theorem of arithmetic, we are going to find out the HCF and LCM. HCF means highest common factor, LCM means least common multiple. So let us understand how can we do that. Before that, let us do the exercise 1.1 and we have to write down as a product of prime factors. So I am going to do a few questions, the rest you can do it as of your own. The first question is 140. So we'll always start with the first prime number. So as I wrote down the prime numbers before. So prime numbers are 2, 3, 5, 7, 11, 13 and so on. So we are going to start with the first prime number. So 140 is divisible by 2, we get 70. 2, 35, 5, 7 and 7, 1. So 140 has to be written like this. You can see all these are prime numbers. So you don't do like this. This is wrong. If you think you can divide by 4, so 4 3 are 12, 4 5 are 20. No. So 140, if you write it as 4 into, then 5 and 7 and 7 1. So 4 into 5 into 7 into 1. This is wrong because 4 is not a prime number. So this is wrong. You cannot do it in this way. So the correct method is this, because you have to write down as a product of primes. So this is first question. One more I do. The second one is 156. So 2, 7 the 40, 2 8 the 2 39 the 3 13 the 13 1 the. So 156 can be written as 2 into 2 into 3 into 13. So this is what you have it as the product of primes. So the next stage of this question is to find out the HCF and LCM. Let us understand how do we find out the HCF and LCM. So what we are going to do after doing this prime factorization, let's say I find out the HCF and LCM of this question itself. So after doing the prime factorization, those numbers which are repeating, write it in power form. So this 2 is repeating, so 2 is coming 2 times. So 2 raised to 2 into 5 into 7. 156 also comes 2 times, so 2 into 2 into 3 into 30. Since this 2 is repeated, some power, look out those common numbers. In HCF we always select the smaller power of the common number. In HCF we select the smaller power of the common number. So here it is more 2 raised to 2. So we will write down HCF as 2 raised to 2. Since there is no 5 and 7 in the other numbers, so HCF will be only 2 raised to 2. In LCM, first of all we will write down the highest power of the common number. Highest power, since here it is 2 raised to 2 only, so we will write down the highest power, that is 2 raised to 2 only, and then write down the remaining numbers. So the remaining numbers are 5, 7, 3 and 13. So we will write down the remaining number 5, 7, 3 and 13. So if you multiply, you get the LCM. So this is how we find out the LCM. We'll do a few more questions to find out the LCM. So let's see, we find out the LCM of another number. We find out the LCM of the question number 2, that is 26 and 91. So 26 and 91. So for that, first of all, we have to factorize 26, 2 and 13, 13 and 1, 91. So 91 is divisible by 7. 7 1 the 7 3 the, so 13 and 1. So 26 can be written as 2 into 13 and 91 can be written as 7 into 13. So when we find HCF, we have to look out for the smaller power of the common number. Smaller power over here, since 13 is the only common number and both has power 1, so we'll write it as 13. LCM can be written as, first of all, the higher power of the common number. The common number is 13. So LCM will be first of all 13 and the remaining numbers are 2 and 7. One example, let's say there is some number which is having 2 raised to 3 into 3 raised to 2 into 5 and another number is 2 into 3 raised to 4 into 7. Let's say there are some two numbers we multiply and we can get the answer. But what is important is that we understand how to find HCF. In HCF, we write down the smaller power of the common number. So common number is 2. This is power 3. This is nothing is power 1. So we write down the smaller power. Smaller power is 2 raised to 1. Then the smaller power of the other common number, that is 3 raised to 2 and 3 raised to 4. The smaller power is 3 raised to 2. And since there is no other common number, so we'll leave over here and then multiply and write down the answer which comes out at 18. For LCM, we write down the higher power. The higher power of the common number, that is the 2 raised to 3 and 2 raised to 1, the higher power is 2 raised to 3. And then over here the higher power is 3 raised to 4. After writing down the higher power of the common number, then we have to find out the whichever number does not have any common, which are not a common number, so those number has to be also included. Those numbers are 5 and 7, so we write down 5 and 7 as well. So whichever the number does not are not common, those number has to be also written. So that is what we are going to do. So if you multiply it, get the LCM. Now there is a relation between the numbers and the LCM. Suppose we take any two numbers again. Let's say we take 8 and 12. Let's find out HCF and LCM of 8. Before we find out the HCF and LCM of 8, we need to factorize 2, 4, 2, 2, 2, 1. So 8 is equal to 2 into 2 into 2. 12, 2, 6, 2, 3, 3, 1. So 12 is equal to 2 into 2 into 3. Then we'll write it in power form. Now, whatever is the smaller power, so that smaller power will be the HCF. The smaller power of the common number, the smaller power of the common number is 2 raised to 3 and 2 raised to 2. So smaller power is 2 raised to 2, that is 4. LCM is the higher power, so higher power is 2 raised to 3 and 2 raised to 2. So the higher power is 2 raised to 3. And also write down the remaining numbers which are left behind, which are not common. So the remaining power is 3. The remaining number is 3. So first the common number, higher power of the common number and the remaining number. So 8 3 is 24. So there is a relation between these numbers and the HCF and LCM. Now this relation is valid only for two numbers, not for three numbers. So the two numbers are 8 and 12. So the relation is that product of numbers equal to HCF into LCM. So product of the numbers are, let's verify whether it is true or not. Product of the number is 8 into 12 is equal to 96. HCF into LCM is, HCF is 4 and LCM is 24. So 4 into 24 is again 96. So you can see, we can verify it as HCF into LCM is product of numbers. So this is applicable only for two numbers, not for three numbers. Now, how to do the questions which has three numbers? So let us do a question from the textbook itself. Finding out the HCF and LCM of three numbers, that is 12, 15 and 21. So let's do it 12, 15, 21. So let's rub out this portion. Let's remove this. I hope you all understand. If there is any question to be asked, you can tell me. You can write it in the comment box. I will explain it again if any topic or any part is not understood well. We are finding out the HCF and LCM of two numbers. So HCF, let's say 2 6 2 3 3 1. So 12 is equal to 2 into 2 into 3. 15, 3, 5, 5, 1. So 15 is equal to 3 into 5. 21, 3, 7, 7, 1. So 21 is equal to 3 into 7. Wherever the numbers repeat, we'll write it in power form. So this is 2 and 2, 2. So we'll write it in power form 2 raised to 2 into 3. And this will keep it as same. Now when we find out the HCF, again the smaller power of the common number. The common number over here is 3. And all of those have 3 as power 1 only. Suppose if it was 3 raised to 1, 3 raised to 2 and 3 raised to 3. So we will take out the smaller power, that is 3 raised to 1. Suppose if it was the case. But here it is 3 raised to 1, 3 raised to 1, 3 raised to 1. So we will write 3. In LCM we write the greatest power of the common number. The greatest power of the common number. Here since all has 3 raised to 1, that is the common number. So we will write only 3. Otherwise, if it was 3 raised to 1, 3 raised to 2 and 3 raised to 3, we will write 3 raised to 3. Then the remaining numbers. So remaining numbers are 2 raised to 2, then 5 and then 7. So multiply and write down that. So 4, 4, 3 is 12, 12, 5 is 60, 60 into 7, 14. So this is we find out the LCM. So for LCM for 3 numbers or for 2 numbers, for any number, LCM and LCM the rule is same. First of all, you have to look for common numbers and then see the power. In HCF we take the smallest power and in LCM we take the greatest power, and after taking the greatest power in LCM we write down the remaining number as well. But in HCF we don't write down the remaining number, we only write down the smallest power of the common number. So that is what is there in HCF and LCM. So for 2 numbers there is a relation that HCF into LCM is equal to product of numbers. I am writing down this product of number as, let's say, x into y. Now there are 4 numbers over here. Simple maths rule says that out of 4 numbers, if you know the value of 3 numbers, the remaining 1 number you can find out. So out of those 4 numbers, suppose if you are given any of the 3 numbers, you can find out any of the 1 number. So let's say the product of the numbers is given. Let's say the numbers are given and HCF is directly given. You can find out the LCM from there. My data that is given over here is that the numbers are given and LCM is given. We directly find out the HCF. You see this rule. So for example, the next question number 4 is that HCF is given to you of HCF of 306 and 657 is given to you as 9. So no need to find out separately the LCM. We'll use this rule. HCF is 9. LCM we need to find out. The 2 numbers are 306 and 657. So LCM is equal to 306 into 657 upon 9. So we'll cut this. 9 7 is 63, 9 3 is 27, so it is 306 into 73. So whatever the answer you get in multiplication, so that is the LCM. So we need not to find out the LCM separately. You can use this result that is there. This concept can be utilized to find out the LCM directly. Otherwise, you will have to do prime factorization of this, prime factorization of this. That is also you are going to get the same answer, but you are not expected to do that way. You are expected to do it in this way. So this is how you have to do. Then, suppose if I write down power of any given number, any power of the given number, and want to find out whether the unit digit will be 0 or not. For example, 4 raised to 1, 4 raised to n belongs to natural number. So my question is that does 4 raised to 1, 4 raised to 2, 4 raised to 3, 4 raised to 4, if you find out the value, does it end with unit digit 0? Does it end with unit digit 0? Let us find out. So, When does any number end with unit digit 0? So the first number with unit digit 0, first number with unit digit 0 is 10. 10 factor is 2 and 5, the factors of 10 are 2 and 5. So it's necessary that the factors of these numbers must be 2 and 5. 2 and 5 both, not only 2, not only 5. 2 and 5 both. So if you see the values of this number, so 4 is to 1 we know is 4, 4 is to 2 we know is 16, 4 is to 3 we know is 64 and so on. So since the factors of 4 is not 2 and 5, so it cannot end with digit 0. To have the factors 2 and 5, then only we can end with digit 0. The number must have factors 2 and 5. So if I ask you, does 6 raised to n end with digit 0? No, because factors of 6 is not 2 and 5, it is 2 and 3. It has to go 2 and 5. You cannot have factors 2 and 3 to end with digit 0. It has to have factors 2 and 5 to end with digit 0. So in any question, let's say I ask you, does 10 raised to n end with digit 0? Yes, because 10 has factors 2 and 5. Then does 8 raised to n end with digit 0? No. Why? Because factors of 8 are 2 into 2 into 2. It does not end with digit 0. So this is how we are going to find out does any number end with digit 0 or not. Then next question, how can we prove that any number is a composite number? To prove any number is a composite number, I told you the concept of composite number, that it can have any other factor apart from 1 in itself. It has any other number apart from factor 1 in itself, then it is a composite number. Means it is not prime. So prime number has factors only 1 in itself. So suppose if I tell you 6 is a composite number because it has factors 2 and 3 as well. But 3 has factors 3 and 1, so therefore this is prime. Whereas this is composite. Suppose if I tell you x square plus 2x is a prime or composite, what we are going to do? We are going to take out x common. The numbers are x and x plus 2. So the factors are x and x plus 2. So therefore we will call it as composite. This number, if it had factors only x square plus 2x and 1, then it will be called as composite. But over here, we have factors x and x plus 2x as well. The factors are x and x plus 2 as well. So we cannot call it as composite. Suppose if I tell you x, here x is a variable. So x I can call it as prime because x has factors x and 1. Any number, so suppose if I say, now here it is binomial because it has 2 terms over here. Suppose if I say 2 into 3 into 4 plus 2, or let's say 2 square, I can take out 2 common, 3 into 4 plus this is 2 square, so 2. So this is composite because it is 2 as a common factor. If I say, let's say 2 into 3 into 4 plus 2 into 3 into 4 into 5, I can take out 2 into 3 into 4 common. If all the terms are common, then 1 is left. After that plus, so plus 2 into 3 into 4 is been taken out as common, so 5. So these are the factors, so therefore it is composite. So composite number has any other factor apart from 1 and itself. So then there is another question, is 7 into 11 into 13 plus 13 is a prime or composite? So over here you can see 13 is common number and there are 2 terms. So in bracket also we are going to get 2 terms. Here there were 2 terms, so in bracket we are going to get 2 terms. This is 1 term, this is 1 term, so in bracket also we get 2 terms. Many students make a mistake that they write it as this. So this is wrong. You cannot write down like this. So the correct way is writing down like this. The other number has to be 1 because 13 is taken out as common. So what is left is 1 is left. So therefore this is composite. So this is how we are going to prove whether any number is composite or prime number. Then the next part out of this is the word problems. In word problems, how do we identify whether any given question requires to be find out HCF or LCM? Remember, HCF whenever we find out, HCF is always the number smaller than the given number. So when we find out HCF in this question, let's say when we found out HCF in this question, the HCF was 3 over here and LCM was 2 raised to 2 into 3 into 5 into 7. So for this question I am talking about the HCF and LCM. HCF is the common number and LCM is the common number as well as the numbers that are left behind. So LCM is this. So you can see that HCF is always smaller than 12, 15 and 21. And when we multiply over here, so you get something 4, 3, 12, 12, 5, 60 and 420. So you can see 420 is a number greater than all that. So in word problem you have to first of all think of your own whether the given answer will come out as a number greater than the given numbers or smaller than the given numbers. If the answer that is going to come out will be smaller than the given numbers, then it will be HCF that you need to find out. And if the number is greater than the given numbers, then you have to find out LCM. So for example, I will tell you that suppose when you go to a sweet seller shop, they decorate it in such a way that you find it attractive. So what they will do, suppose you see a few type of burfis over there. Let's say you see Kaju Katri. There are two type of Kaju Katris usually we see. One is the regular Kaju Katri and another is the Kesar Kaju Katri. So he does it what? He stacks one above the other, keeping the height same. So let's say this is one Kaju Katri above the other. So what he has done, he has kept 4 regular Kaju Katris over here, another stack of 4 regular Kaju Katris, another stack of 4 regular Kaju Katris one beside the other, and let's say few Kesar Katris, Kesar Kaju Katri. So one above the other. So why does he keep it that way? To look it more attractive, just that is just the way. So when I ask you a question, let's say there are 9 regular Kaju Katris, and there are 12 Kesar Katris. So in one stack, this is one stack, how many sweets will be there? So in one stack, how many sweets will be there? So obviously in one stack you cannot have more than 9, there will be less than 9. In one stack you cannot have more than 12, it will be less than 12. So you need to find out HCF. So HCF of 9 and this is 16. So this is 16 and this is 12. I'm sorry. So this is 12 and this is 16. So HCF of 12 and 16 is 4. HCF of 12 and 16 is 4. So therefore you can see there are 4 Katris over there in the stack. Similarly, when you keep your textbooks and notebooks, so you will keep the, because the shelf are of the same height, so you will keep the textbook and notebook in the same shelf. So to accommodate the textbook and the notebook, assuming they are all of the same thickness, how many notebooks or textbooks you are going to keep it in one stack? So you have to find LCM. When do we find LCM? We find LCM when the value will be more than the given numbers. For example, we have a race between 2 children. Obviously one will be faster and another will be slower. So the 2 children, let's say one is child A, another is child B. Child A is faster than child B. So when child A completes this one whole round, because the child A is faster than child B, then child B will be somewhere over here when it completes the race. So child A is over here, child B is over here. They keep on running because A is maintaining the same speed, assuming they both maintain the same speed. So when they maintain the same speed, so A goes in this way, completes one round. So because B was starting from here when A was starting from here from the second round, so because B is slower, so after some time B will be over here. Then A keeps on running, B will be over here. A keeps on running, B will be over here. So slowly B will be going behind the A. And one stage will come when you might see A will be over here. In that case, A must have completed one more round than B. In that case, A has completed one more extra round than B. Many times in Olympic we see that race, that you might have seen that the first athlete is running so fast that it has overtaken the last athlete. So does it mean that the last athlete was ahead of the first? No. It means that the first athlete has completed one extra round than the last athlete. So the time taken by the athlete will be greater than the time taken to complete one round. So in that case, we'll find out the LCM. For example, in the next question, that Sonia takes 18 minutes to drive one round, whereas Ravi takes 12 minutes to drive the same, and they both start from the same position. After how much time will they meet? So we have to find out the LCM, because they are going to meet with a greater time than the values of 12 and 18 that is given for Ravi, so Sonia and Ravi. So they both are going to take greater time. So if the time is greater, it means we have to find out the LCM. So LCM of finding out 12 and 18 is very easy. That is 36 orally you can also find out. So in this math series today I have done with the first exercise. In the next exercise, in the next class, I am going to on the next Sunday 10:30 a.m. due to some technical glitch. I wasn't able to start today's math series at the proper time at 10:30, but from the next Sunday onwards the technical issue has been resolved and we could start from 10:30 sharp. We'll start with the proving of irrational numbers, that is proving root 2, root 3, root 4 all as irrational numbers, and then we'll do with that topic. I hope that video won't be that big, and then every Sunday we'll have one class of one chapter. If it might take 2 days to complete one chapter or 1 day in one complete chapter depending upon the length of the chapter. Maybe trigonometry or triangle might take 6, 7, 8 lectures. I hope you found this video useful. If you find it useful, you share with your friends, and then also join me live from next time onwards. I hope there won't be any such problem that we face today, and we'll be resolving them. So subscribe and like the videos and share it with your friends. We'll continue with the next test series on next Sunday at 10:30 a.m. sharp. Okay, thank you. Have a nice day.